Welcome everyone to our lecture of the topic of laws of motion. So we'll be starting with the questions which we talked about in the last video. So the first question which we have is question number 4. So let us jump to it. The pulleys and strings shown in the figure are smooth and of negligible mass as shown in the figure. So these are the strings and there are three masses m, root 2 m and m. So for equilibrium, theta should be. So we know that the condition of equilibrium, or when we see the term equilibrium, our inference is that sum of forces acting on the body in x and y direction is 0, which can be combined to say that sum of force vectors acting on the body should be 0 vector. So what is happening in this case? So we know that the tension acting in the string would be equal to mg if we are to assess this block. So that tension is equal to mg. System is in equilibrium. Force has to be 0 on it. And for root 2 mg block, this is root 2 m into g. Tension forces are acting at an angle as there are two strings. So it says that tension is acting like this. So if we take the component of tension in vertical direction, so that would be t cos theta times 2 is equal to root 2 mg, which gives us cos theta is equal to 1 upon root 2. This gives us theta is equal to 45 degree and gives us the answer. Next question, question number 5. The force on the pulley by the clamp is dash. So this is our clamp in this particular question. This is the clamp and this is the pulley. This is the mass capital M. The mass of the clamp, the mass of the pulley is also given M. This is the mass of pulley. So we are given mass of the pulley. The clamp is massless and the mass of the block is capital M. So what is the force on the pulley by the clamp? So on the pulley, what force is acting? We know on the pulley the tension acts. So tension would act in the direction of string. So tension number 1. Again, this string again is acting vertically down or downward direction tension in this direction. This tension would be equal to capital M into G, since this tension is basically balancing the mass of the block, which is capital M, and we would have one more force, which is the weight of the pulley. So the pulley's weight is small m into G. So to counter all that, there would be force exerted by the clamp on this pulley, which would be able to counter the force number 1, 2 and 3. So we have to find what are this, how to find the, so we have to find the FC, the clamp force. So we know that if we were to draw if we were to concentrate the whole pulley at a single point, then we would say that the tension acting on the pulley is in this direction, in vertical downward direction, and this value Fg. The force acting on the clamp is in this direction, Fc. So we can use Pythagoras Theorem. We would say that if we were to combine forces number 1, 2 and 3, then we will get a force F which would be equal and opposite to the force Fc, because that would balance out the force F. If we can combine any three forces, then it should be equal to the fourth force acting on the body, as the body is in equilibrium. So combining mg plus t should give us simply mg plus t, and combining these two forces should be by Pythagoras theorem. So F should be equal to mg plus t, which is capital Mg squared plus again capital mg, which is this t squared, and square root. So this would give us m plus capital M squared plus capital M squared square root g, and this should be equal to the force exerted by the clamp. So this should be the option number D. Next we are to do question number 6. So these two masses are 1 kg, 1.0, 1.0 kg, and we have to do this. By doing this, we mean that we have to find the acceleration of these two blocks who are kept on a pulley. So you have a block mass m, mass m. Both the blocks are having same mass. Okay, so both the blocks are having mass 1 kg. This distance is given as some 4 meters. This distance is given as some 4 meters. This distance is given as some 3 meters, and this distance is given as some 5 meters. So for this particular triangle, we try to remember that the angle in front of the side 4. This is a first of all right angle triangle. It's a Pythagoras triangle. The side in front of 4 is approximately 53 degree. The side in front of 3, the angle in front of 3 is approximately 37 degrees. So this is something which we can remember. In addition to that, let us draw the force body diagrams of the blocks. Let's say this is block A, let's say this is block B. So for block A, we have selected the system, the gravitational force, the tension force, and the normal force. So we know that what is the angle which the gravitational force makes with the normal, that is the angle of inclination. This angle, the angle drawn in green, this angle is 37 degree. And let us say for side B, we would say that again for the block B, gravitational force is mg, mass is remaining same, normal reaction n dash, and tension T. So we have changed normal reaction. The normal reaction would be different, but the tension would be same since the string remains the same. It is going to over the pulley. So which block is going to go down, which block is going to go up, that becomes the question. So definitely the block which is standing on the steeper angle would go down. So which block stands on the steeper angle? So the block which lies on the smaller side stands on the steeper angle. So the block B stands on the steeper angle, so it would go down. The block B is going to go down, and the block A is going to go up. So this is how we decide that when the angle inclination is greater, definitely the block would start going in that direction. But this is the case when both the blocks are having same mass. What if the blocks had unequal masses? What then? How do we find the direction of acceleration? So to find the direction of acceleration, we don't have to predetermine the direction of acceleration as such. If we can predetermine it, it is good, but it is not that big deal. Even if we take the opposite direction of acceleration, then also we'll get the positive values of normal reaction and tension, and no force would get some undescript value. If we were to take the direction of acceleration opposite to what is actually happening, then simply the value of acceleration would come out to be a negative value, which will show us that the direction of acceleration is opposite to what we have chosen. So in this particular case, if I have to draw the equations, we know that we draw the equation in the direction of acceleration. So we will say that for A, tension minus the component of mg in this direction, which is mg sine 37 degree, is equal to ma, and for block B we are drawing mg sine 53 degree, the component of mg in this direction, mg sine 53 degree, minus tension would be equal to acceleration in this direction. If we were to add these two, you would get mg sine 53 minus sine 37 equal to 2ma. The m and m get cancelled. We get g is equal to 4 by 5 minus 3 by 5, which you can find from this particular triangle, is equal to 2a. Or we would say that a is equal to g by 10. So this is the acceleration of both the blocks in the direction which we have chosen. Let us do the next question. In the next question, we have a 50 gram block. Here G represents gram, 100 gram and 500 gram. This angle is some 30 degree, and we have to find the magnitude of acceleration. This angle is 30 degree. So I hope this one is clear how we derived the equation. We simply chose the direction x. We wrote the forces in x direction, which are tension, and the component of mg in x direction, which is opposite in x direction. That's why it's ma. And similarly for b, we wrote mg sine 53 degree. Here this direction was chosen as positive, as our acceleration is in this direction, and then we wrote the whole equation. So this is how we do these kinds of question. We have a figure. We have a mass, 100 gram mass. We have two pulleys. One pulley is directly closer to the 50 gram mass, and the other pulley is closer to 500 gram mass. This mass is some 500 gram, and we have to find the acceleration of the whole system. So let's say 500 gram mass is going down. Let us assume that the heavier mass, this is pretty kind of heavy mass, it is going down. The 100 gram mass would move in this direction, and 50 gram mass will move in this direction. So here the direction of acceleration is kind of, or even in which direction they are moving is decided pretty easily. What we have to take care of is the tension's value. So tension in this case, in this string, would be T1 and acting in this way, and in this string number 2, it would become tension T2 as the string has changed. So now let us write the equations. So for the mass, 50 gram mass, we will write T1, that is the upward force, minus 50 gram force. Let us say we are writing it as 50 grams into G, mg. So tension minus mg, let's say this is m1g is equal to m1, or we would say 50 gram mass into acceleration. Equation for block number 1. Similarly, we write equation for block number 2. We would say T2, that is the force in the positive direction which we have chosen, minus 100 gram mass sine 30 degree. Let us draw the FBD for mass 100 grams. 100 gram downward, normal reaction, tension T2, tension T1. This angle is 30 degree. The component of 100 gram in this direction is 100 gram sine 30 degree into G. Into G is equal to 100 gram into A. minus T1. For the third mass, we would say 500 gram into G minus T2 is equal to 500 gram into A. When we will be adding the equation number 1, 2 and 3, we would get 500 G minus 50 G from this equation and 50 G from this equation. Say sin 30 is half, it would become half. So T2 would cancel out and T1 would also cancel out. So all these would be adding up. T2 would cancel out here and T1 would cancel out here. So this would become some 650 grams into A, and this is whole outside G. So this would come out to be some 400 grams divided by 650 grams into G is equal to A. So this would come out to be some 8G by 13. Yeah, if you multiply 2 up and down, you will get this. So this is the value of acceleration of the whole system. So thank you for joining for this particular video. In the next video, we'll be starting straight motion, as I said in the last video. So thank you.